So the title of this video is if you don't have an indeterminate form, you don't have to do anything fancy. And that's something that's important for you to remember. In the past few videos, we worked through some limit problems involving a couple tricks. But the reason we had to use those tricks, like taking the multiplying and dividing by the conjugate, it's also called rationalizing the denominator, or dividing the numerator and denominator by the highest power of x, that was because we were presented with an indeterminate form. But there are times when you're not presented with an indeterminate form, and if you remember the indeterminate forms, the indeterminate forms that you most frequently encounter are 0 over 0, infinity over infinity, and infinity minus infinity. There's some others, but you won't see them as frequently in an introductory calculus course. So if you don't have one of these, you don't have to do anything like you don't have to use any tricks. And I'm going to show you an example that should drive that home. So here we'll be looking at the limit as x tends to 3 of 4x squared minus 6x plus 1 divided by x squared plus 1. And before you do anything, before you even try to factor or anything like that, what you should do is check in both the numerator and denominator, check in the whole expression. As x gets close to 3, what happens to everything else? This 4x squared is going to get close to 4 times 3 squared. This minus 6x is going to get close to minus 6 times positive 3. This 1 is just going to get close to 1. This x squared is going to get close to 3 squared, and 1 is going to get close to 1. So 3 squared is 9, times 4 is 36, 3 times 6 is 18, plus 1. 3 squared is 9, plus 1. 36 minus 18 is 18, plus 1 is 19, and 9 plus 1 is 10. So here we don't have one of those indeterminate forms. So we're done after this. And after we get to this, we found the limit. It's 19 over 10. We only had to do the fancy stuff when we encountered an indeterminate forms, and these are the three that you will see most frequently. Hopefully that gives you an idea why we bothered to go through all the algebra that we did in the previous problems. But we don't always have to do that.